Annual cash inflows that will arise from two competing investment projects are given below. At an 18% discount rate, what is the present value of each project? Notice both projects A and B have unequal cash flows over a 4-year period, years 1 through 4. Also notice that the cash flows in project A are increasing over time, 3,000, 6,000, 9,000, and 12, while project B has the same total cash flows, but the cash flows are decreasing over time. We will find that project B has the higher present value because its cash flows, the larger cash flows, occur sooner. Let's go ahead and calculate the present value of project A. The $3,000 cash flow in year 1 needs to be discounted back at the 18% interest rate for 1 period. The factor is 0.847. So we multiply the $3,000 by 0.847 and get a present value of $2,541. The $6,000 we receive in year 2 needs to be discounted back at 18% for 2 periods. The present value factor is 0.718. We multiply that by the $6,000 to get a present value of $4,308. The $9,000 we receive in year 3 needs to be discounted back at 18% for 3 years. The present value factor is 0.609. We multiply that by the $9,000 cash flow and we get a present value of $5,481. The $12,000 we receive in year 4 needs to be discounted back at 18% for 4 years. The present value factor is 0.516, and we multiply that by $12,000 to get the present value of $6,192. When we sum the cash flows, present value of the cash flows in years 1 through 4, we get a present value of project A of $18,522. We could have also calculated the present value using our financial calculator. Using our financial calculator, we would discount the year 1 cash flows of $3,000 back for 1 period at 18% interest. We'll enter n equals 1, 18 for the interest rate, 3,000 for the future value, and solve for a present value of $2,542. The year 2 cash flow will enter n equals 2, 18% for the interest rate, and now $6,000 will be the future value, and we'll solve again for the present value and get $4,309. The year 3 cash flow will enter 3 for the number of periods, 18 for the interest rate, $9,000 cash inflow will be our future value, and we'll solve for a present value of $5,478. The year 4 cash flow will be discounted back at 18% for 4 periods and have a present value of $6,189. When we sum the present value of the cash flows for years 1 through 4, we get a total present value of $18,518. This is different than the present value we calculated using the tables because the tables have approximate present value factors. Project B. Let's go ahead and find the present value of the cash flows. The factor for the first year cash flow of $12,000 will be the same 0.847 that we found for Project A. That's 1 year at 18%. Multiply that by 12,000 and we get a present value of that year 1 cash flow of $10,164. The year 2 cash flow will be discounted back at 2 periods with a present value factor of 0.718, which we multiply by $9,000 to get a present value of $6,462. The year 3 cash flow will be discounted back using a factor of 0.609 and has a present value of $3,654. The year 4 cash flow of $3,000 will be discounted back for 4 periods at 18% with a present value factor of 0.516. We multiply that by 3,000 and get a present value of $1,548. The sum of the 4-year present values is $21,828. Using our financial calculator, for the year 1 cash flow, we enter n equals 1 for the number of periods, 18 for the interest rate, 12,000 for the future value, and solve for a present value of $10,169. The year 2 cash flow, we use n equals 2. Solving for the present value, we get $6,464. The year 3 cash flow will be discounted back for 3 periods, so N will equal 3. And again, I will be 18%, and our future value is 6,000. And again, solving for a present value, we get $3,652. The present value of the year 4 cash flow is $1,547, and the total sum of the 4 present values is $21,832. Again, notice the present value of project B is higher than the present value of project A because the earlier cash flows are larger for project B. That increases its overall present value. We would select project B.